Hello everyone, my name is Hayman Aziz. The title of this video is This Equation Destroys the World. And simply the equation is as the following. Politics to power science is equal to destruction. The main elements and characters of this video are as follows. For example, if you look at these two, these were the United States president. And then certainly the power here is Oppenheimer. And Oppenheimer was one of those big scientists in which probably is assumed to be the father of atomic bomb. And the reason for producing this video practically is because over 70 years, this atomic bomb here was used in the Second World War or after the Second World War. And then secondly, here before few months, there was a movie produced by Hollywood here on Oppenheimer, and then talking about this story, which probably some part may be similar to this video in which I'm producing. Then the second part here are certainly Hitler. And then the power of Hitler definitely is going back to this big scientist who was known as Heisenberg. He was one of those quantum physics scientists. Then in history, if you look at it here, we have used weapons through history from very basics like knives, machete, and etc. Or maybe, for example, later on, archeries and arrows, or perhaps maybe catapults, for example, and later on we developed to artillery. Then secondly, here, if you look at it nowadays, for example, we have got fighter jets, and we have got chemical weapons, and we have developed, for instance, here, nuclear atomic bombs, and then cruise missiles in which is crossing continents. And there are many more, but these are just some simple samples of those weapons in which we have. Then there is an interesting point. All weapons we have developed throughout history and even nowadays, they have got some common points, and these common points are similar in all of them. Whether you use knife to kill people, whether you use nuclear bomb to kill people or rockets to kill people, they are all the same. All are built to destroy and kill humans. Then secondly, here, for example, all of these have been built or are built by scientists, experts, and engineers, and certainly not politicians. Politicians cannot build weapons. And throughout even history and even nowadays. But the order of using those weapons are by politicians. Otherwise, the scientists themselves cannot order to use those weapons to kill people. Then the other point here is all of these weapons, in which shortly we will see in the next slide, are built on properties of matter. So it means properties of matter have been enable us to build those weapons. Then lastly here, always there are businesses in which benefiting from these weapons. There are companies, there are businesses in which they make money out of building these types of weapons here, even nowadays. Now, there are some principle of all weapons in which is energy. This is a little bit physics, but the physics play a role here, or maybe even chemistry. Like if you look at it here, like using knives, swords, and etc., it is or it was used by muscles. And then where the energy of the muscles come from? From chemical energy. Then, for instance, here you have got archery or maybe catapult. The origin of this energy is elastic potential energy, which this equation we have learned it from basics of mechanics of material, half kx squared. Here, I'm not deepening too much to its physical meaning here, but this is the energy in which we have. X is the extension and k is the elasticity property of that material in which we use. Then you have got chemical energy in which, like in guns, cannons, and this is some form of reaction between different elements or compounds that form this amount of the energy, and the energy is used to, for example, here send those guns or maybe shoot those guns. Now, the other point here is, which is the main focus of this video, is nuclear energy. Nuclear energy simply is in the heart of matter. And the origin of this equation simply is this, mc squared. So it means the connection between, or the conversion between, matter in mass and energy through this simple equation. Then, now the question is, what is nuclear energy? So this is, as I said, the main focus of this. From basics of science, we have learned that if you take a simple atom, is made from nucleus and then electrons surrounding like clouds to this nucleus. And the nucleus itself is made from two different types of particles. One of them is proton and one is nucleus. So it means all of them are called nucleus or nucleons, protons and neutrons. Then there is an interesting point here. If, for example, you take the whole nucleus and then if you measure its mass, and then later on if you separate the particles here and then you measure the mass of the individual and add all of them, the answer will be different from that. So it means if they are all combined together or close enough together, then their masses for all will be less than the mass if we were to add individually. Although definitely you will not expect that, for instance, in any other cases, if you have with a number of marbles, if you put all of them together, or if you put them separately here and measure separately, the masses are exactly identical. But this is not the case here. The reason for this difference in the mass is a binding energy between those. So an energy in which is binding those nucleons together. Then if by some means we can take out this energy to outside it means the atom, this energy will be huge. And this energy will be even tens of millions of times greater than a normal chemical energy. That's why this is the origin of atomic bomb. Then, in 1905, Einstein produced this simple equation, and the left-hand side is energy, the right-hand side is matter. So it means simply here, if you have got matter, and then if you convert it fully into energy through this equation, the amount is huge because of the square of speed of light. Speed of light is huge. Then later on, in 1920, Eddington introduced the concept of binding energy theory, in which these particles are bonded together by some sort of energy while they are inside the nucleons. Then finally here, for example, in 1930, the very first experiment for the evidence of this was carried out by this German scientist, Otto Hahn. Then this is a very fundamental fact nowadays in which we know the conversion between mass and energy, or energy and mass, and the binding energy between these particles. Now, there are two different ways in which we can take this energy out from the heart of the matter. those two types of, or those two different methods here are, or ways. One of them is called fission. Fission simply means if you have got a heavy nucleus, and this heavy nucleus, if you split it into smaller ones, then as the result, because those particles will come, or some particles go to one side, some particles to go to the other side, and this binding energy in which we talked about it earlier on can be taken out. And this binding energy is huge, certainly. And here we are not talking about one atom, we are talking about billions of atoms in a kilogram, or maybe a certain amount. Then the amount of the energy will be. The basic principle is as the following. Normally, uranium has got a number of isotopes, and simply the isotopes are exactly the same element of uranium, but with different number of neutrons. The very main one in which is interesting here is this, okay? Uranium-236. What is happening? So uranium-235 in nature, if you bombard it with a slow motion neutrons, then suddenly here this becomes uranium-236. But uranium-236 is very unstable. And then almost instantaneously here it is split into two smaller atoms. And these two smaller atoms, one of them is krypton and one of them is barium. And then as the result of this fission, three more neutrons are also ejected from this, plus a huge energy. Then this is simply the principle of fission of uranium. Then, in simple sentence, fission is splitting a heavy nucleus to smaller ones. And as this result, energy is released. Then there's something here in which we call a chain reaction. So what is a chain reaction? The chain reaction simply is, because you don't need to ignite, or you don't need to, for example, bombard every single uranium atom. It means uranium-235 with neutrons. Then what is happening if, for example, the very first one is bombarded with this neutron, then because there are other neutrons in which they are also ejected or emitted from this reaction here, they are hitting other uranium-235, 235, then another 235, then it means practically here this reaction may not be controllable. Then it will continue almost to the end. Exactly the same as you have got a container in which contains petrol, and then if you just ignite a very, very little part of it, and almost instantaneously the entire container may catch fire. This is similar to that, or not exactly. Okay? Then this is the principle of the well-known atomic bomb. This principle. Now, definitely here, uranium is not the only source in which we can use it for this purpose. We have got even plutonium-239. Plutonium-239 can be done through similar to this process. So if this is bombarded with neutron, this plutonium-239 will be converted into other, for example, elements. These elements are xenon, and the other element is zirconium. And then plus, if you notice that, three more neutrons. So probably similar to the fission of uranium, chain reaction may take place, because these neutrons are hitting other plutonium-239, and this process will continue. Then, as this result, you have got energy released. But there is a little difference between this fission and fission of uranium, because the fission of plutonium here has got modes. So it means, what exactly we mean by modes? When you have got this reaction, not necessarily 100% will be this. There is a chance of 73%, a probability of 73% that the reaction will be this. or there is a 27% probability in which still the plutonium will remain as 240, but slightly the energy of this plutonium will change because some gamma ray will be emitted to the outside. But even if, for example, you assume 73%, still this is a large probability here. There are a few important points, especially here related to this plutonium. Plutonium, just for your information here, is a man-made. It's not something in which naturally exists in nature here. And for the very first time in which scientists built it was in 1940. And secondly, here it has got an advantage over uranium-235. For example, the critical mass is much more less, almost 5 times less than the critical mass of uranium. So what does it mean by the critical mass? Simply, critical mass is the minimum mass in which you require so that this chain reaction will continue and all the fuel of uranium or plutonium you have will run out and then will be converted into energy. And because this amount, the critical mass, is less, certainly practically this may be better, definitely, rather than uranium, because if you were to use uranium at the same enrichment level, then you require 50 kilograms, but if you use plutonium, it is 11 kilograms. But definitely here you need to be realistic. This critical mass depends on the level of the enrichment in which we do. Then the next step here is the second type of this nuclear energy is coming from fusion. Fusion is exactly in opposite to fission. So what does that mean? It means you have got light elements. If light elements here, you combine them together, then exactly the same idea, energy will be released. The very simplest one we have is from isotopes of hydrogen. The hydrogen in which we have, it has got 3 isotopes, one with 1 proton, the other one is 1 proton and neutron, which is called deuterium, and then one with 1 because all of them, they have got the same 1 proton, but the number of neutrons are different. This is tritium. And this is the normal, ordinary one in which we are familiar with it, and then even we have learned it from basics of science. Then what is happening here, this fusion, practically here you have got deuterium. This is a very, very simple version of it, and this is tritium. So if these two merge together, fuse together, they will form this, and then suddenly here, or almost instantaneously, because this is unstable, it forms the nucleus of helium, which is 2 proton and 2 neutron. Energy is released and 1 neutron. Then this amount of energy release is simply from the fusion. But there is one fact here we need to know. The amount of the energy in which is released from fusion, again here, is much, much more higher rather than fission. But the case or the environment of building fusion may be more difficult because it requires a lot of pressure, a lot of temperature here. But if, for example, you arrange those, then later on, the energy in which is released is much, much more higher than even the one in which you spend. Usually in stars, this is the concept of fusion reaction, nuclear reaction in which is taking place, that the stars can release energy, including our sun. Now, the next point here is, this is practically the principle of hydrogen bomb, because in reality you have got atomic bomb in which the principle is fission, and you have got hydrogen bomb. Hydrogen bomb exactly functions in the following way. So it means you fuse light elements, mainly hydrogen certainly, and you produce nucleus of helium because you combine them, lighter elements to a heavier one, then energy is released as result. Now, this is an interesting one, the race. So when or how the race started to build this nuclear arsenal here from the start. The race originally was between Germany and USA. And the Germany means in terms of politics here was to the power of Heisenberg, and USA was to the power of Oppenheimer. So Heisenberg was the mastermind of building a nuclear bomb for Germany, and Oppenheimer was the mastermind of building atomic bomb or nuclear bomb to USA. Then, as we stated, this is Heisenberg, which is one of the greatest scientists, and especially in quantum physics, and he was assumed to be the youngest who won Nobel Prize in 1933 due to his development of uncertainty principle in quantum physics, but obviously this is not the purpose of this video to deepen more. Then in 1938, although he wasn't Nazis, but then he was certainly promised by the Nazis here that he must be working for Germany. And that's why, for example, even they gave him this sign here so that he will be loyal. Although the assumption is he was loyal to German rather than the Nazis during that time, especially here. In 1939, what he did here, he traveled to USA to meet Oppenheimer, because the scientific community during that time, definitely they knew each other. And then especially here during that time, many German scientists escaped and fled Germany here due to the atrocities committed by Nazis. And then, but certainly he wasn't one of those. Then when he met Oppenheimer, Oppenheimer really admired him. And then even he said to him, okay, your paper, I mean, these papers in which he produced, has made me or have made me, for example, a big theoretical physicist because I really like your work. And then even he advised him, Oppenheimer advised him, why don't you stay here? Why don't you go back? Why do you go back to Germany here? And then you should escape in the same way as the other scientists, including Einstein, who fled Germany. He said, no, I'm very loyal to Germans, and then I'm not doing that. And he was even, according to some historians, maybe he became a bit upset from that statement. Then I'm not staying here and I will go back to Germany. Then in 1939, he was given a green light to start atomic bomb, then to start the project. And during that time, there was an interesting point, although still the Second World War hasn't started, because the Second World War started in September, or the 1st of September. But during August, Einstein here wrote a letter to Roosevelt and then said to him, do you know that Germans have already built atomic bomb? Then we should do something about it. If, for example, Hitler gains this atomic bomb here, maybe he will kill all of us. Then I'm not quite sure exactly how he got this information, although it wasn't true because they did not yet build the atomic bomb. But Roosevelt took it seriously. And then during that time, the communication wasn't like nowadays we had. But at the meantime, here, Germans started to build. Then they captured almost 1,200 tons of uranium in Belgium so that they can start the project. Then during 1941, or in October 1941, on the realization of this letter in which he received from Einstein, he started to order for doing a project on building an atomic bomb. And then he got 1,250 tons of uranium. He bought it, for example, here to start the project. Then in 1942, from the other side, a trial experiment was carried out by Heisenberg in a lab, but unfortunately badly failed, and then even caused the lab to damage and blown up, and hardly these scientists could escape from the damage of the bomb. Later on, the Nazis decided no need for more investment and we cannot continue because we haven't got money, and at the same time, apparently it seemed that he could not, Hitler especially here, he could not trust scientists anymore. Then the project stopped. Then it means Germans or Nazis here could not build atomic bomb anymore. But from the other side, the Americans started a project. They named it Manhattan Project. And this Manhattan Project is the very first project was for developing atomic bomb. And the main mastermind, it means in terms of army, was by Leslie Groves. He was an engineer in army, and then perhaps maybe he was well trusted by American government here. Then what he did, okay, he approached Oppenheimer and then explained to him the situation, although he was advised by some colleagues here, why you are just approaching Oppenheimer here to build this project and to start this project. There are many other scientists in which they had even Nobel Prize, even physicists, great physicists here, because Oppenheimer never won Nobel Prize due to various reasons. Then he said to his colleagues here, no, because I can only trust this man here. Really, this is the man in which practically can do that. The others may know theory or may know, for example, other information, but I don't think they are at the level that they can build an atomic bomb. But this chap can do it here. I can trust him. And probably later on, that's true. He proved it. Then he became the main boss of this project. Then this project practically involved almost more than 130,000 people working from different levels, mathematicians, for example, physicists, biologists, engineers, and this was, especially at that time, would be even perhaps compared to nowadays, was a very big project and almost costed more than $2 billion. Then the project started. Then from the other side here, in May 1945, when the Nazis was then certainly here, failed in the Second World War, and then Heisenberg and some other scientists were captured by the Allies, okay, and then almost all the dreams in which Nazis they had in this gone. From this side here, if you look at it, in July 1945, the very first test of this bomb was carried out and it was successful. And then the Americans, especially during that time, although the Second World War was almost nearly over, except Japan, in which it wasn't surrendering. And then Truman was the president of the United States. Then he ordered the use of this 3 weeks later on the very first city of Japan, Hiroshima, and then 3 days after on Nagasaki, and almost of the total 220,000, 250,000 were killed almost within hours. And then this made Japan to surrender, and then probably the Second World War almost fully completed and then finished. This is one of those cities that was destroyed by this atomic bomb. Okay, you have got many other photographs maybe on the internet. So 1 minute silence. Now, there are some interesting information about those atomic bombs used to destroy these two cities. This is just maybe some very basic information, but if you want to deepen more, there is no way in which you can finish it in one video. Firstly, size-wise, if you look at these two bombs, the one in which used in Hiroshima or on Hiroshima was on the 6th August 1945, and 3 days later by the other bomb on Nagasaki. This was called Little Boy. And this little boy simply here, if you look at the size of both, they are almost like the size of a typical human, for instance, here in terms of length. And then if you look at some other information, the principle of the gun system here was uranium. And the power, or maybe the amount of the energy in which produced to destruct the city, was 15 kiloton TNT, because usually the unit of destruction of nuclear bomb is measured by kilonewton or kiloton of TNT. But if you look at the other one here, the other one was named Fat Man, but the principle of this was plutonium. So exactly both of them fission concept, but this is uranium and this is plutonium. And then that's why even if you look at it here, the destruction power of this was higher than that one. This was 15 kiloton TNT, but this is 21 kiloton TNT. And there was a little concept here. What was that? It means there was an implosion concept. So they compressed, for example, the plutonium here to increase its ability for the critical mass, because if you compress it, certainly the density becomes more, and then as the result, the critical mass becomes less. Then it means with less amount of plutonium, you can still produce the same destruction. And then the next point here is these are the nowadays pictures in which we have on nuclear arsenals in which we have. Certainly the difference is huge. These are the ones in which we use them in the Second World War. But if you look at nowadays, for example, we have got like this is a hydrogen bomb, and this hydrogen bomb practically is 50 megatons, millions, but this is kilo. So it is massive, massive. And then if you look at the height of the mushroom cloud, almost reached 200,000 feet, while the one in which we used in Japan was almost reaching 20. So practically this is almost 10 times as high as this, maybe million times as more powerful as this. So it means probably one of this may destroy the entire country. Hopefully they will not be used. And then in terms of countries, these are the units usually of the energy in which we have. 1 kiloton TNT is equivalent to 4.184 times 10 to the power 12 joules, and 1 megaton is 4.184 times 10 to the power 15 joules. Then in terms of countries, these are the main countries are Russia and America, certainly, in which they have got the most number of these nucleus. Then there are some other countries like China, France, and so on. But relatively here, for example, these are much, much, much in terms of number smaller than these two. And then almost, if you look at it, maybe we have got a total of more than 15,000 nuclear arsenals. But do not forget, this is the information in which we have. It means maybe there are some hidden information in which no one knows, could be the same amount, could be even more. We don't know about them here in which these countries they have. Now there is an interesting question here. This interesting question is, for example, where is the ethics? So if, for example, all of those arsenals in which we use just to destroy human, then where is the ethics? The answer is easy. So we don't need to complicate it. The answer is easy. This answer is only in dictionary. So we haven't got it in real world. So there is no ethics in the real world. Because if you build a weapon to kill human, there is no ethics, certainly. Now, there is an interesting thing here. What about if all those energies in which we have in these nuclear arsenals and we use them for peaceful means? Peaceful means like generating electricity mainly. So this is just a simple, interesting calculation. I have made it myself. Maybe this is a rough calculation, but it's not bad. It has got probably something like maybe real. So the total energy from these nucleus, in which I assumed if we have got 15,000 of them, but I certainly assume that there may be more. Then if you multiply by all of those energies in which they have, then this is the amount of the energy in which all these arsenals they have. Then if I convert it to the units of kilowatt hour, simply here you can easily convert this into kilowatt hour. This is 6.1 times 10 to the power 14 kilowatt hours. Then if, for example, I assume that, although maybe this is probably semi-realistic on average, if one household uses 2,500 kilowatt hour per year, this is unit of electricity, then if we assume that the population of globe at this moment may be around 7.5 billion, 8 billion, will become 8 billion, then 7.5 times 10 to the power 9 people. And then if for simplicity I assume that each household on average is 3 heads, then it means the number of households in which we have on the planet could be around 2.5 times 10 to the power 9. And then if we assume that this is the consumption of that energy in which we had, then it means practically here we need this amount of energy. Because kilowatt hour simply is unit of energy. Then if we divide the one in which we have from the arsenals by this figure, so almost this is lasting more than 100, 120 years. If we were to use that just for peaceful mean, then probably even we don't need any sources. And this is a very clean source, by the way, for power. And then even nuclear power is quite environmentally friendly for us. So it means, but unfortunately, this is not the case. Our madness may not allow to use it for this purpose. We just would like to use it for killing people. Hopefully you have enjoyed this video, and this is my email if you have got any comments or any points in which you would like to send it to me. And this is the end. Thanks for listening.